Standing in the shadow of the Great Pyramid of Giza, it's hard not to feel a sense of awe. This ancient wonder, built over 4,000 years ago, still towers over the desert, a testament to human ingenuity. But here's the thing: its construction defies everything we think we know about engineering. No cranes, no bulldozers, no computers, just raw human effort, ingenuity, and a mastery of techniques that modern experts are still trying to fully understand. How did ancient people move stones that weighed as much as 50 elephants across miles of desert? What tools did they use to carve and place these massive blocks with such precision? And perhaps most intriguing of all, what secrets did they know that we've yet to uncover? In this video, we're diving deep into the mysteries of ancient construction, exploring the incredible techniques and tools that allowed civilizations to build monuments that still leave us speechless today. Get ready to uncover the hidden wisdom of the past and see how these ancient builders achieved the impossible without a single modern machine. Let's begin. Picture this: tens of thousands of workers moving in perfect harmony under the blazing sun, hauling massive stone blocks across the desert. The Great Pyramid of Giza rises inch by inch, a testament not just to physical labor, but to something far more profound: human ingenuity. Ancient civilizations didn't have cranes, bulldozers, or power tools, yet they achieved feats of engineering that still leave us in awe today. How? By relying on creativity, resourcefulness, and the power of collective effort. Take the pyramids, for example. Historians believe workers used ramps made of mud brick or compacted earth to drag stone blocks weighing several tons up to incredible heights. But ramps alone weren't enough. Ancient builders also mastered the use of levers and pulleys, simple yet brilliant tools that allowed them to lift and maneuver heavy materials with precision. These weren't just random acts of trial and error. They were deliberate, calculated solutions born out of necessity and a deep understanding of physics, even if they didn't have the formal terminology we use today. Archaeologists have uncovered evidence of how these ancient teams worked together, dividing tasks and coordinating their efforts with astonishing efficiency. It wasn't just about brute strength, it was about problem solving on a massive scale. For instance, some theories suggest that workers used sledges to transport stones, pouring water on the sand to reduce friction and make the journey smoother. This kind of innovation shows how ancient builders turned obstacles into opportunities, using the resources they had in ways we might never have imagined. What's even more fascinating is the mindset of these ancient engineers. They didn't see limitations as barriers, they saw them as challenges to overcome. Historians point out that this relentless drive to innovate and adapt is what allowed civilizations like the Egyptians, the Romans, and the Incas to create structures that have stood the test of time. And as we'll see next, their ingenuity didn't stop at ramps and levers. They developed a whole arsenal of tools and techniques that pushed the boundaries of what was possible, laying the groundwork for the architectural wonders we marvel at today. One of the most astonishing feats of ancient engineering lies in how civilizations managed to extract enormous stone blocks from quarries without the aid of modern machinery. Picture this: workers standing at the edge of a rugged quarry, armed with nothing but copper chisels, wooden wedges, and sheer ingenuity. These tools, though seemingly primitive by today's standards, were the keys to unlocking the Earth's resources. For example, in ancient Egypt, laborers quarried limestone blocks for the pyramids by first identifying seams in the rock, natural weak points where the stone could be split. They would then use copper chisels to carve channels into the stone, followed by wooden wedges soaked in water. As the wedges expanded, the rock would crack along the desired line, allowing workers to extract massive slabs with remarkable precision. But the challenges didn't end there. In places like Peru, where the Incas carved granite, one of the hardest stones on Earth, the process required even greater skill and patience. Workers would use stone hammers and abrasive sand to slowly grind away at the granite, shaping it into perfectly fitted blocks that still puzzle modern engineers today. The precision of these cuts, often so tight that not even a knife blade can slip between them, speaks to the mastery of their techniques. Of course, quarrying on such a scale wasn't without its difficulties. Workers had to deal with the immense weight of the stones, the risk of fracturing them during extraction, and the logistical nightmare of moving these blocks from the quarry to the construction site. Yet, ancient builders found solutions to these problems, often through trial and error, and sometimes through sheer determination. For instance, the Egyptians used ramps and sledges to move stones across the desert, while the Incas relied on a network of roads and manpower to transport granite blocks across mountainous terrain. This brings us to the next great challenge these ancient engineers faced. Once the stones were quarried, how did they move them? Imagine the effort required to haul a single multi-ton block, let alone hundreds or thousands of them, across miles of uneven ground. The solutions they devised were as ingenious as they were labor-intensive, and they laid the groundwork for some of the most iconic structures in human history. Picture this: massive stone blocks, some weighing as much as several elephants, being transported across vast deserts, rugged terrains, and dense jungles, all without the wheel. How did ancient civilizations achieve such feats? The answer lies in ingenuity, teamwork, and a deep understanding of their environment. Take the ancient Egyptians, for example. To move the colossal stones for their pyramids, they relied on a clever combination of sledges and lubrication. These sledges, essentially large wooden platforms, were dragged across the desert sands. But here's the twist: they didn't just rely on brute force. Workers would pour water or oil in front of the sledges, turning the sand into a slippery surface that reduced friction. This simple yet brilliant method made it possible to transport stones weighing several tons with relative efficiency. It's a testament to how ancient engineers turned everyday resources into solutions for monumental challenges. Meanwhile, in Mesopotamia and Mesoamerica, civilizations like the Sumerians and the Maya employed another ingenious technique: log rollers. Imagine placing a massive stone block on top of a series of logs. As the stone moved forward, workers would rotate the logs, creating a rolling path. This method not only distributed the weight more evenly, but also significantly reduced the effort required to move heavy materials over long distances. Combined with the sheer muscle power of hundreds or even thousands of workers, these log rollers became an essential tool in constructing some of the ancient world's most iconic structures. Experts have marveled at the efficiency of these methods. Studies suggest that even with rudimentary tools, ancient builders could move stones at a rate of several feet per minute, a remarkable achievement given the technology of the time. These techniques weren't just about strength, they were about strategy, coordination, and a deep understanding of physics long before the term even existed. But moving the stones was only half the battle. Once these massive blocks reached their destination, the real challenge began: lifting them into place. How did ancient builders manage to stack these stones with such precision? That's a story of innovation, persistence, and perhaps a little bit of ancient magic, or so it might seem. Stay with us as we uncover the secrets of how these civilizations defied gravity and built structures that still leave us in awe today. One of the most fascinating innovations in ancient construction was the humble ramp, a simple yet revolutionary tool that transformed how massive structures were built. Think about it: moving blocks of stone weighing several tons up the steep sides of a pyramid seems nearly impossible without modern machinery. But the ancient Egyptians had a solution: ramps. These weren't just small slopes, they were colossal earthen structures, sometimes stretching for hundreds of meters, designed to haul stone blocks to dizzying heights. Imagine the effort it took to build these ramps themselves, only to dismantle them once the pyramid was complete. It's a testament to the ingenuity and determination of these ancient builders. Now, here's where it gets even more intriguing. Archaeologists have long debated the exact design of these ramps. Some argue they were straight, running directly up one side of the pyramid. Others suggest zigzag patterns, snaking back and forth to reduce the incline's steepness. And then there's the spiral theory, which proposes that ramps wrapped around the pyramid's sides in a continuous upward curve. Each design has its merits and challenges, and while we may never know for sure which method was used, the debate itself highlights the complexity of ancient engineering. These weren't just random piles of dirt, they were carefully planned systems, tailored to the specific needs of each project. But the Egyptians weren't the only ones to master the art of the ramp. Take the Assyrians, for example. They used ramps to construct their towering ziggurats, massive stepped temples that reached toward the heavens. Unlike the pyramids, ziggurats required ramps that could support both the weight of materials and the movement of workers along their steep, narrow steps. The Assyrian approach shows how different cultures adapted the concept of ramps to suit their unique architectural styles and needs. It's a reminder that innovation isn't about reinventing the wheel, it's about refining and reimagining tools to fit the task at hand. What's truly remarkable, though, is the precision involved in using these ramps. Building a ramp is one thing, but ensuring it aligns perfectly with the structure being built is another. Even the slightest miscalculation could lead to instability or misalignment, throwing off the entire project. This level of accuracy speaks volumes about the skill and knowledge of ancient engineers who managed to achieve such feats without the aid of modern technology. It's a quiet yet powerful reminder of how much we can learn from the past. And speaking of precision, let's not forget the role of alignment, a critical factor in ancient construction that took these projects from impressive to awe-inspiring. The precision and alignment achieved by ancient builders is nothing short of astonishing, especially when you consider they lacked the laser-guided tools and digital measurements we rely on today. How did they manage to create structures with such incredible accuracy? The answer lies in a combination of ingenuity, observation, and a deep understanding of natural forces. Let's start with some of their most essential tools. The plumb bob, for instance, was a simple yet brilliant device, a weighted string that used gravity to determine perfectly vertical lines. This allowed builders to ensure their walls were straight and their foundations level, even without modern levels or laser pointers. Water levels were another ingenious solution. By filling a long, shallow trough with water, ancient engineers could create a perfectly flat reference point. This method was particularly useful for large-scale projects, like the aqueducts of Rome or the sprawling temple complexes of Egypt. And then there were shadow casting techniques. By observing the movement of shadows throughout the day, builders could align structures with incredible precision. This wasn't just about aesthetics, it was about harnessing the sun's predictable patterns to guide their work. But perhaps the most awe-inspiring examples of ancient precision are found in the pyramids of Egypt and the stonework of the Inca. The Great Pyramid of Giza, for example, is aligned with the cardinal directions north, south, east, and west, with an accuracy of just a fraction of a degree. How did they do it? Experts believe the ancient Egyptians used a combination of star observations and geometric calculations to achieve this feat. They weren't just building monuments, they were creating a celestial map in stone. The Inca, on the other hand, took precision to a whole new level with their stonework. Their walls, made of massive, irregularly shaped stones, fit together so perfectly that you can't even slide a piece of paper between them. This wasn't just about strength, it was about a deep understanding of geometry and an almost obsessive attention to detail. As one expert put it, the Inca didn't just build walls, they solved puzzles in stone. What ties all of these techniques together is a profound respect for the natural world and the cosmos. Ancient builders didn't just see the stars as distant lights, they saw them as guides, markers of time, and symbols of order. And this brings us to the next chapter of their story, the role of astronomy in construction. By looking to the skies, ancient civilizations didn't just build structures, they built connections between the earth and the heavens. Imagine standing in the shadow of the Great Pyramid of Giza, looking up at the night sky. Thousands of years ago, the builders of this colossal structure did just that. But they weren't just stargazing, they were mapping the heavens to guide their work. Ancient civilizations didn't have satellites or GPS, but they had something just as powerful, the stars. Their deep understanding of astronomy allowed them to align their most iconic structures with celestial events, creating connections between the Earth and the cosmos that still leave us in awe today. Take the Great Pyramid, for example. Its sides are aligned almost perfectly with the cardinal directions north, south, east, and west. But how did they achieve such precision? Archaeologists believe the builders used the North Star, or Polaris, as a reference point. By tracking its position during the night, they could determine true north with remarkable accuracy. And it wasn't just about direction, the pyramids were also aligned with the solstices, marking the longest and shortest days of the year. This wasn't a coincidence. For the ancient Egyptians, the solstices held deep spiritual meaning, symbolizing the cycles of life, death, and rebirth. By aligning their monuments with these celestial events, they were weaving their architecture into the very fabric of the universe. But Egypt isn't the only place where ancient builders looked to the stars for inspiration. Across the sea, in what is now England, stands Stonehenge, a mysterious circle of massive stones that has puzzled researchers for centuries. One of its most fascinating features is its alignment with the summer solstice. On the longest day of the year, the sun rises directly over the heel stone, casting its rays through the center of the monument. This alignment wasn't just for show. Archaeologists believe it served both practical and spiritual purposes. For the people who built Stonehenge, the solstice likely marked a time of celebration, renewal, and connection to the divine. The stones themselves may have acted as a calendar, helping them track the seasons and plan agricultural activities. What's truly remarkable is that these ancient builders achieved such precision without modern tools or technology. They relied on careful observation, trial and error, and a profound respect for the natural world. For them, astronomy wasn't just a science, it was a language, a way of communicating with the gods and understanding their place in the universe. And while we may never fully grasp the spiritual significance these alignments held for them, we can still marvel at the ingenuity and dedication it took to create such enduring monuments. So how did they turn this celestial knowledge into stone and mortar? That's where the tools come in. While the stars gave them direction, it was their clever use of simple yet effective tools that brought their visions to life. But that's a story for the next part of our journey. Ancient builders didn't have the luxury of modern machinery, but that didn't stop them from creating tools that were both ingenious and effective. Starting with the most basic implements like stone hammers and flint blades, early humans relied on what nature provided. These tools were simple, yet they laid the foundation for something extraordinary, a gradual evolution of technology that would shape civilizations. Over time, as humans discovered metals like copper and bronze, their tools became more sophisticated, allowing them to tackle harder materials and more ambitious projects. Take the adze, for example, a tool that looks like an axe but is designed for shaping wood. Used across cultures from ancient Egypt to Polynesia, the adze was essential for carving and smoothing surfaces, enabling builders to craft everything from canoes to intricate wooden beams. Then there's the chisel, a seemingly humble tool that became indispensable for stonework. Whether it was carving hieroglyphs into temple walls or shaping blocks for pyramids, the chisel's precision made it a cornerstone of ancient craftsmanship. And let's not forget the saw, which evolved from serrated stone edges to metal blades, revolutionizing how builders cut through wood and stone. What's truly fascinating is how these tools were adapted to different environments and challenges. In regions with abundant stone, like the Andes, builders perfected techniques for cutting and shaping massive blocks without metal tools. Meanwhile, in Mesopotamia, where clay was plentiful, tools were designed to work with softer materials. This adaptability speaks volumes about the resourcefulness of ancient societies. Experts often point out that crafting these tools required not just skill, but an intimate understanding of materials and physics knowledge that was passed down through generations. But innovation didn't happen overnight. It was the result of countless experiments, failures, and breakthroughs. Trial and error played a huge role in ancient engineering, as builders refined their techniques and tools to meet the demands of their time. This process of continuous improvement is a testament to human ingenuity, a reminder that even without modern technology, ancient builders were capable of extraordinary feats. And as we'll see next, this spirit of experimentation wasn't just about tools. It shaped the very foundations of ancient engineering itself. Ancient builders didn't have the luxury of modern engineering handbooks or computer simulations. Instead, their greatest teacher was trial and error, a process of relentless experimentation and keen observation. Picture this, a team of workers laboring for months to erect a towering arch, only to watch it collapse under its own weight. It might sound like a setback, but for ancient engineers it was a lesson. Every failure brought them closer to understanding the limits of their materials and the principles of physics that governed their designs. Take the Romans, for example. Their mastery of the arch didn't happen overnight. Early attempts often resulted in structures that buckled or cracked, but each failure revealed something new. They learned that the weight distribution had to be perfectly balanced, and the stones had to fit together with precision. Over time, these lessons led to innovations like the keystone, a single wedge-shaped block at the top of the arch that locks the entire structure into place. This breakthrough wasn't just luck, it was the result of countless experiments and a deep understanding of how forces interact. But arches weren't the only challenge. Domes, with their sweeping curves, presented an even greater puzzle. The Pantheon in Rome, with its massive concrete dome, is a testament to this iterative process. Historians believe that earlier attempts at dome construction likely failed due to inadequate support or poor material choices. But each failure taught builders something new, whether it was the importance of using lighter materials at the top or the need for reinforced walls to bear the dome's weight. What's truly remarkable is how these ancient engineers adapted and persevered. They didn't see failure as an end, but as a stepping stone to success. Historians often point to their resilience as one of the key factors behind their achievements. They were problem solvers, constantly refining their techniques and pushing the boundaries of what was possible with the tools and knowledge they had. And here's where things get even more fascinating. While trial and error played a huge role, it wasn't just guesswork. Behind every successful structure was a growing understanding of mathematics, a tool that allowed builders to predict outcomes and refine their designs with greater accuracy. But more on that in a moment. For now, let's appreciate the ingenuity of these ancient minds who turned setbacks into stepping stones and laid the foundation for engineering marvels that still stand today. What if I told you that the pyramids of Egypt or the Parthenon in Greece were not just feats of brute strength, but masterpieces of mathematical precision? Ancient builders didn't just stack stones, they calculated, measured, and applied geometry with an accuracy that still leaves modern engineers in awe. Take the Great Pyramid of Giza, for instance. Historians and mathematicians have long marveled at its alignment with the cardinal points north, south, east, and west, with an error margin of just a fraction of a degree. How did they achieve such precision without GPS or laser levels? The answer lies in their deep understanding of mathematics and geometry. One of the most fascinating examples is the use of the Pythagorean theorem. Yes, the one you probably learned in school long before Pythagoras himself was even born. Evidence suggests that ancient Egyptians used this principle to create perfectly square corners for their monumental structures. By measuring 3 units on one side, 4 units on the other, and 5 units diagonally, they could ensure a perfect right angle. This simple yet brilliant method allowed them to lay the foundation for structures that have stood the test of time. But the Egyptians weren't alone in their mathematical mastery. The Greeks took it even further, embedding geometry into the very soul of their architecture. Take the Parthenon, for example. Its design is a symphony of precise ratios and proportions. The columns are not just evenly spaced, they're slightly curved to correct optical illusions, making the temple appear perfectly straight to the human eye. This technique, known as intosses, is a testament to their advanced understanding of geometry and human perception. As architectural historian John R. Senseni puts it, the Greeks didn't just build temples, they crafted mathematical poetry in stone. Geometry wasn't just about aesthetics, though, it was also about stability. Symmetrical designs distributed weight evenly, ensuring that structures could withstand earthquakes, storms, and the passage of time. The Romans, inspired by the Greeks, took this knowledge and ran with it, creating aqueducts, amphitheaters, and domes that still stand today. Their use of arches and circles based on geometric principles allowed them to build structures that were both beautiful and incredibly durable. So, what does all this tell us? It's a reminder that ancient builders weren't just laborers, they were mathematicians, engineers, and artists. They used their knowledge of geometry not just to create buildings, but to craft legacies that would endure for millennia. And speaking of legacies, let's not forget another crucial element that played a vital role in ancient construction: water. But that's a story for the next section. Water wasn't just a resource for ancient civilizations. It was a tool, a partner in their monumental building projects. Imagine trying to level the foundation of a massive structure like the Colosseum or the Great Pyramid without modern laser levels or precision instruments. Ancient builders had a solution: water. By filling trenches or channels with water, they could create a perfectly level surface. The principle was simple but brilliant. Water naturally finds its own level, so by observing the surface of the water, they could ensure their foundations were even and stable. This method was so effective that it's still used in some forms today, a testament to its ingenuity. But water's role didn't stop there. It also became a means of transportation. In ancient Rome, the construction of aqueducts wasn't just about bringing water to cities. It was also about moving heavy materials. Builders would float massive stone blocks along canals, reducing the need for backbreaking labor. The aqueducts themselves, marvels of engineering, were built with precision using water levels to ensure they sloped perfectly, allowing gravity to do the work of moving water over vast distances. Now, let's take a journey to Machu Picchu, where water played an equally vital role. The Incas carved intricate channels into the mountainside to direct water through the city. These channels weren't just for irrigation, they were also used to stabilize the ground and prevent erosion. The precision of these systems is astonishing, especially when you consider they were built without metal tools. Archaeologists studying Machu Picchu have marveled at how the Incas used water to shape their environment, turning a steep, rocky landscape into a thriving city. Even more fascinating is how water became a cutting tool. Ancient builders discovered that by directing water flow over time, they could erode and shape stone. This technique was used in quarries to extract large blocks of stone with minimal effort. It's a reminder that ancient civilizations didn't just work against nature, they worked with it, harnessing its power to achieve their goals. These examples reveal a common thread: the ingenuity of ancient builders. They didn't have modern technology, but they had an intimate understanding of their environment and the creativity to turn natural forces into tools. As we marvel at their achievements, it's impossible not to wonder what other secrets they might have unlocked. And speaking of secrets, let's not forget another incredible resource: ancient builders relied on animal power. From oxen to elephants, animals played a crucial role in moving materials and even shaping landscapes. But that's a story for the next section. Ancient civilizations didn't just rely on human ingenuity and muscle. They also turned to the natural strength of animals to accomplish seemingly impossible feats of construction. Imagine the sheer power of an ox, its massive shoulders straining as it dragged a sledge loaded with stones across rough terrain. Or picture an elephant, its trunk curling around a massive block of granite, lifting it with ease to place it precisely into position. Animals weren't just companions or tools, they were indispensable partners in the monumental projects that shaped the ancient world. Take the use of oxen, for example. In many cultures, these sturdy animals were harnessed to pull heavy sledges or carts loaded with building materials. Their strength allowed workers to transport enormous stones over long distances, even across uneven ground. This was especially crucial in places like Egypt, where the construction of pyramids required moving limestone and granite blocks weighing several tons. Without the tireless efforts of oxen, such feats would have been nearly impossible. But oxen weren't the only animals lending their strength to ancient builders. In India, elephants played a vital role in constructing some of the most intricate and awe-inspiring temples. These intelligent creatures were trained to lift and position massive stones with remarkable precision. The temples of Hampi, for instance, stand as a testament to the synergy between human vision and animal power. Elephants didn't just move materials, they became part of the construction process, their strength and dexterity enabling the creation of architectural marvels that still captivate us today. Meanwhile, in the arid deserts of the Middle East, camels emerged as the unsung heroes of ancient construction and trade. Their ability to traverse vast stretches of sand with heavy loads made them indispensable for transporting materials like stone, wood, and even water across harsh landscapes. Without camels, the construction of cities like Petra or the expansion of trade routes that connected empires would have been far more challenging. These resilient animals bridged the gap between isolated communities, enabling the exchange of ideas, resources, and technologies that fueled progress. The use of animal power wasn't just practical, it was a reflection of the deep connection between ancient societies and the natural world. By harnessing the strength of animals, builders were able to achieve what would have otherwise been unimaginable. Yet, as impressive as animal power was, it was just one piece of the puzzle. Another force, equally transformative, was also at play: fire. From shaping tools to forging materials, fire became a cornerstone of ancient engineering, paving the way for even greater innovations. One of the most fascinating tools in the ancient builder's arsenal wasn't made of stone or metal, it was fire. Imagine standing in a world without modern machinery, where fire was not just a source of warmth or light, but a transformative force that shaped entire civilizations. Ancient builders harnessed fire in ingenious ways, using its heat to manipulate materials and create structures that still stand today. Take, for example, the process of hardening clay bricks. By carefully controlling the intensity and duration of fire, early builders could turn soft, malleable clay into durable bricks capable of supporting massive structures. This technique was especially crucial in regions like Mesopotamia, where sun-dried bricks alone wouldn't withstand the elements. The result, cities like Babylon rose from the earth, their walls fortified by fire-hardened bricks that endured for centuries. But fire's role didn't stop there. In places like ancient Egypt and the Andes, builders used fire to split massive stone blocks. By heating the rock and then rapidly cooling it with water, they could create cracks along precise lines, allowing them to quarry and shape stone with remarkable accuracy. This method was both practical and resourceful, turning what might seem like a destructive force into a precise tool for construction. And let's not forget lime, the key ingredient in ancient mortar. By burning limestone at high temperatures, early civilizations produced quicklime, which, when mixed with water, created a strong binding material. This lime mortar was essential for everything from Roman aqueducts to Mayan pyramids, holding stones together so tightly that many of these structures still stand today. Fire wasn't just a tool for shaping materials, it also played a vital role in preparing construction sites. In the Americas, indigenous builders used controlled burns to clear dense forests and create open spaces for their cities and ceremonial centers. This practice not only made construction possible but also enriched the soil, blending practicality with environmental stewardship. Experts today marvel at the effectiveness of these ancient techniques. Studies have shown that fire-hardened materials often rival modern equivalents in durability, proving that ancient builders had a deep understanding of their tools and materials. Their methods weren't just functional, they were masterful. As we reflect on the role of fire in ancient construction, it's impossible to ignore the spiritual significance it held for many cultures. Fire was more than a tool, it was a symbol of transformation and creation, often intertwined with religious beliefs and rituals. This connection between the practical and the spiritual offers a glimpse into how ancient builders saw their work as more than just engineering. It was an act of reverence, a way to connect with the divine. Ancient builders didn't just construct structures for the living, they built for the gods and the afterlife. Religion and spirituality were at the heart of many ancient construction projects, shaping not only the design but also the purpose of these monumental works. Temples, tombs, and monuments weren't just feats of engineering. They were sacred spaces carefully crafted to honor deities, ancestors, and the mysteries of the cosmos. Take the Great Pyramids of Giza, for example. These towering structures weren't merely tombs for pharaohs, they were gateways to the afterlife. Ancient Egyptians believed that the pharaoh's soul would ascend to the heavens, and the pyramid's precise alignment with the stars was thought to guide this journey. The entire construction process was infused with rituals, from the laying of the first stone to the placement of treasures within. Historians suggest that every aspect of the pyramid, from its shape to its orientation, was laden with spiritual meaning, reflecting the Egyptians' deep connection to the divine. Then there's the Parthenon, perched atop the Acropolis in Athens. This iconic temple wasn't just a building, it was a tribute to Athena, the city's patron goddess. Every column, every sculpture, and every detail of its design was meant to honor her power and wisdom. The Parthenon wasn't solely a place of worship, it was a symbol of Athens' identity, a testament to the city's devotion to its protector. Historians point out that the precision of its construction wasn't just about showcasing skill, it was about creating a space where the divine and the mortal could meet. Even in cultures far removed from Egypt and Greece, we see this same intertwining of faith and construction. In Mesoamerica, the towering pyramids of the Maya and Aztecs served as both temples and astronomical observatories. These structures weren't just places to pray, they were cosmic maps aligning with celestial events to mark sacred moments in the calendar. For the Maya, building a pyramid wasn't just an act of labor, it was a ritual, a way to connect with the gods and ensure the balance of the universe. What's fascinating is how these spiritual beliefs drove innovation. The need to honor the gods pushed ancient builders to refine their techniques, to experiment with new materials, and to achieve levels of precision that still baffle us today. It wasn't just about building something strong or beautiful, it was about creating something sacred, something that would stand as a bridge between the earthly and the divine. But how did ancient societies organize the massive labor forces needed to bring these spiritual visions to life? That's where we're headed next, into the world of labor organization, where we'll uncover how thousands of workers came together to turn these sacred dreams into stone and mortar. Imagine the sheer scale of organizing thousands of workers to build something as monumental as the Great Pyramid of Giza. How did ancient civilizations, without the tools of modern logistics, manage to coordinate such massive efforts? The answer lies in their remarkable systems of labor organization and workforce management. Ancient societies relied on a combination of skilled laborers, slaves, and even volunteers, each playing a critical role in bringing these colossal projects to life. In Egypt, for instance, records from Deir el-Medina, a village of workers who built the tombs in the Valley of the Kings, reveal a highly structured system. Skilled craftsmen like stonemasons and carpenters were organized into teams, each led by an overseer who ensured tasks were completed efficiently. These overseers acted as the middle managers of their time, coordinating between the architects who designed the structures and the laborers who executed the plans. It wasn't just about brute force, precision and expertise were key, but it wasn't just skilled workers who made these projects possible. Slave labor was also a significant part of the workforce in many ancient cultures, though the extent of its use varied. In some cases, like in Mesopotamia, prisoners of war or conquered peoples were forced into labor. Yet, it's important to note that not all workers were coerced. In Egypt, evidence suggests that many laborers were actually paid workers or volunteers who believed their efforts contributed to something greater, whether it was honoring their pharaoh or ensuring their own place in the afterlife. The coordination didn't stop at the workforce itself. Architects and engineers played a pivotal role in planning and problem solving. They had to account for everything, from the precise alignment of stones to the logistics of transporting materials across vast distances. In Egypt, for example, architects used simple but effective tools like plumb bobs and levels to ensure accuracy, while engineers devised innovative ramps and pulley systems to move massive stone blocks. What's truly fascinating is how these ancient systems weren't just about labor, they were about resource management too. The success of these projects relied on a steady supply of materials, food, and tools, all of which had to be carefully tracked and distributed. This brings us to another critical piece of the puzzle: trade. The ability to acquire materials like copper for tools, timber for scaffolding, and even food for workers depended on well-established trade networks. These networks didn't just support construction, they tied entire civilizations together, enabling them to achieve the unimaginable. When we think about the towering pyramids of Egypt or the sprawling cities of Mesoamerica, it's easy to focus on the finished structures. But the real story begins long before the first stone was laid, with the incredible trade networks that made these projects possible. Ancient builders didn't just rely on what was nearby. They sourced materials from hundreds, sometimes thousands of miles away. This wasn't just about hauling rocks and wood, it was about managing resources on a massive scale, creating intricate systems of trade, and solving logistical challenges that would make even modern engineers pause. Take ancient Egypt, for example. To build their iconic monuments, the Egyptians needed vast quantities of cedar wood, prized for its strength and durability. But cedar didn't grow in the Nile Valley. Instead, it came from the forests of Lebanon over 1,000 miles away. This wasn't a simple delivery. It required coordinated efforts across land and sea. Ships had to be built, crews organized, and routes mapped out to transport the timber down the coast and up the Nile. Archaeologists have uncovered evidence of this trade in the form of shipwrecks and inscriptions, showing just how vital these networks were to Egypt's architectural achievements. Similarly, in Mesoamerica, obsidian, a volcanic glass used for tools and ceremonial objects, was traded across vast distances. The ancient Maya sourced this material from volcanic regions like Guatemala, transporting it through a network of rivers and trade routes. The logistics of moving such a fragile yet essential resource reveal the sophistication of their trade systems. Archaeologists studying these routes have found that obsidian wasn't just a practical material. It held cultural and symbolic significance, making its trade even more complex. But how did ancient societies manage such large-scale operations without modern technology? The answer lies in their ability to adapt and innovate. They used rivers and coastal waters as natural highways, built specialized ships and carts, and established alliances with neighboring cultures to secure resources. These trade networks weren't just about moving goods, they were about building relationships, sharing knowledge, and creating systems that could sustain enormous construction projects over generations. As impressive as these trade networks were, they were just one piece of the puzzle. Ancient builders didn't just rely on external resources, they also had to adapt to their environments, using the land itself to their advantage. This interplay between trade and environmental adaptation is where the story of ancient construction truly comes to life. Ancient builders didn't just construct structures, they worked in harmony with their surroundings, crafting ingenious solutions to the challenges posed by their environments. Think about it, in the scorching deserts of the American Southwest, the ancestral Pueblones carved their homes directly into cliffs, using the natural rock as both shelter and insulation. These cliff dwellings, like those at Mesa Verde, weren't just practical. They were a testament to their deep understanding of the land. By building into the cliffs, they avoided the harsh desert heat during the day and retained warmth during cold nights, all while blending seamlessly into the landscape. On the other side of the world, in the dense forests and river deltas of Southeast Asia, ancient builders took a completely different approach. Here, stilt houses became the norm. Elevated above the ground, these structures protected against flooding, pests, and even wild animals. Timber, abundant in these regions, became the material of choice, showcasing how local resources dictated building practices. This wasn't just about convenience, it was about survival, sustainability, and a profound respect for the environment. But it wasn't just about the materials. Ancient builders also considered the long-term impact of their work. Take adobe, for example. In arid regions like the Middle East and parts of Africa, mud bricks were a game changer. They were easy to produce, required minimal tools, and provided excellent insulation against extreme temperatures. And the best part, once a structure was no longer needed, the materials could simply return to the earth, leaving little to no environmental footprint. Experts today point to these practices as early examples of sustainable architecture, showing how ancient societies prioritized living in balance with nature. What's fascinating is how these adaptations weren't just practical, they were deeply cultural. The ancestral Pueblones' cliff dwellings weren't just homes, they were sacred spaces connected to their spiritual beliefs. Similarly, Southeast Asian stilt houses often reflected social structures, with elevated platforms symbolizing status and community. These structures weren't just built to last, they were built to tell a story. As we marvel at these ancient techniques, it's impossible not to wonder, how did they pass down such knowledge? How did they ensure that future generations could replicate their successes? That brings us to the next chapter in this journey, the role of writing and record keeping in preserving and advancing these ancient building traditions. From symbols etched into stone to detailed manuscripts, the tools of communication played a crucial role in shaping the architectural wonders we still admire today. Long before blueprints and digital models, ancient builders relied on something equally powerful: the written word. Writing and record-keeping were the backbone of monumental construction projects, allowing civilizations to plan, execute, and preserve their architectural achievements for generations. In Egypt, for example, hieroglyphs weren't just symbols carved into temple walls. They were a sophisticated way to document everything from the dimensions of a pyramid to the daily rations of workers. Detailed records like those found at the Giza Plateau reveal how thousands of laborers were organized, fed, and housed during the construction of the Great Pyramid. These inscriptions weren't just practical, they were a testament to the precision and ambition of ancient engineering. Meanwhile, in Mesopotamia, the cradle of civilization, cuneiform tablets served a similar purpose. These clay artifacts, etched with wedge-shaped characters, captured everything from material lists to labor contracts. One fascinating example comes from the construction of the ziggurates, massive step temples that dominated the skyline. These tablets often included precise measurements, timelines, and even prayers to ensure the gods' favor. It's remarkable to think that these ancient builders left behind such meticulous accounts, offering us a window into their world. The Romans took record-keeping to another level. Architectural manuals like those written by Vitruvius laid out principles of design, construction techniques, and even advice on selecting materials. These texts weren't just technical guides, they were works of philosophy, blending art and science to elevate construction to a form of cultural expression. Vitruvius' writings influenced not only his contemporaries but also architects for centuries to come, underscoring the enduring power of written knowledge. But beyond the practical, writing also played a symbolic role in ancient construction. Inscriptions often served as a bridge between the physical and the divine, embedding spiritual meaning into the very stones of a building. Whether it was the hieroglyphs adorning an Egyptian tomb or the Latin inscriptions on a Roman arch, these symbols connected the human effort to something greater, a belief in eternity, in legacy, in the divine. And speaking of symbolism, this brings us to another fascinating layer of ancient construction, the role of art. From the intricate carvings on temple walls to the grand mosaics of Roman villas, art wasn't just decoration. It was a language telling stories, conveying power, and immortalizing the vision of those who built these wonders. But that's a story for another moment. When we look at the ancient structures that have stood the test of time, it's not just their engineering that captivates us, it's the stories they tell. Art and symbolism were woven into the very fabric of these constructions, serving as a visual language to communicate the values, beliefs, and aspirations of the cultures that built them. From the towering temples of the Maya to the grand columns of ancient Greece, every carving, mural, and statue was intentional, carrying messages that transcended mere decoration. Take, for example, the Mayan temples. Their surfaces are adorned with intricate carvings that depict gods, rulers, and mythological scenes. These weren't just artistic flourishes, they were a way to honor the divine, commemorate victories, and even record historical events. The Mayans believed that these carvings connected their earthly realm to the spiritual world, ensuring the favor of their gods. Historians suggest that the placement of these carvings was deliberate, often aligned with celestial events like solstices or equinoxes, blending art with astronomy in a way that still leaves us in awe today. Similarly, Greek temples were more than just places of worship. They were canvases for storytelling. Statues of gods and heroes lined their facades, each one a symbol of power, virtue, or divine protection. The Parthenon, for instance, featured elaborate friezes depicting scenes from Greek mythology, like the birth of Athena or the battle between the gods and the Titans. These weren't just decorative, they were meant to inspire, educate, and remind visitors of the cultural and religious ideals that defined Greek society. What's fascinating is how these artistic elements were integrated into the construction process itself. Ancient builders didn't see art as something separate from their structures. It was part of the architecture. The carvings on Mayan temples were often created as the stones were being laid, and Greek sculptors worked alongside stonemasons to ensure that every statue and relief fit seamlessly into the design. This holistic approach tells us that these societies didn't just build for function, they built for meaning. But art in ancient construction wasn't just about beauty or spirituality, it also served as a form of communication. In many cases, the carvings and statues acted as a record of achievements, a way to immortalize rulers or celebrate victories. And here's where it gets even more intriguing. Some of these artistic elements also hint at the role of warfare in shaping these civilizations. After all, many of the scenes depicted on these structures involve battles, conquests, and the glorification of military might. Which brings us to the next chapter in our exploration: how warfare influenced the construction of ancient monuments and what these structures reveal about the societies that built them. One of the most fascinating aspects of ancient construction is how it was shaped by the constant threat of warfare. For civilizations under siege, survival often depended on their ability to build structures that could withstand attack or deter it altogether. Walls, fortresses, and even moats weren't just architectural feats. They were life-saving innovations born out of necessity. Take the Great Wall of China, for example. Stretching over thousands of miles, it wasn't just a barrier. It was a complex network of watchtowers, signal stations, and garrison posts designed to keep invaders at bay. The wall wasn't built in a single era. It evolved over centuries, adapting to new threats and technologies. Each section tells a story of a civilization determined to protect its people, its culture, and its way of life. But defensive architecture wasn't limited to massive walls. In Mesopotamia, one of the world's earliest civilizations, cities like Babylon and Ur were fortified with towering walls and strategically placed gates. These weren't just physical barriers, they were psychological ones too. The sight of an imposing fortress could be enough to discourage an invading army from even attempting an attack. Experts point out that these designs weren't just about strength, they were about strategy. Walls were often built with multiple layers, creating a maze-like structure that confused and slowed down attackers. Moats, on the other hand, added an extra layer of defense, forcing enemies to navigate water before even reaching the walls. What's truly remarkable is how these ancient builders combined practicality with ingenuity. They didn't just throw up walls and hope for the best. They thought critically about terrain, materials, and even the psychology of warfare. For instance, the placement of watchtowers along the Great Wall allowed for rapid communication across vast distances, giving defenders a critical advantage. And in Mesopotamia, the use of baked bricks instead of mud bricks made fortifications more durable against both weather and weapons. These weren't just structures, they were masterpieces of human ingenuity, born out of the need to survive in a dangerous world. As we marvel at these ancient defenses, it's impossible not to wonder, what drove these civilizations to innovate on such a grand scale? The answer lies not just in the fear of invasion, but in the relentless human spirit to adapt, overcome, and thrive. And speaking of innovation, our next section will dive into how ancient builders pushed the boundaries of what was possible, transforming challenges into opportunities that shaped the course of history. Imagine standing beneath the towering dome of the Pantheon in Rome, its massive ceiling seemingly floating above you without any visible support. How did ancient builders achieve such a feat without modern technology? The answer lies in their relentless drive to innovate, pushing the boundaries of what was thought possible and forever changing the course of architecture. Ancient builders didn't just rely on brute strength or trial and error, they engineered groundbreaking solutions that still leave us in awe today. One of the most transformative innovations was the Roman arch. Before its widespread use, structures were limited by the weight-bearing capacity of straight beams and columns. But the arch allowed builders to distribute weight more efficiently, creating stronger, more stable structures that could span greater distances. This simple yet revolutionary idea became the foundation for aqueducts, bridges, and even the grandeur of amphitheaters like the Colosseum. It wasn't just a building technique, it was a leap forward in engineering that reshaped the physical and cultural landscapes of the ancient world. Then there's the dome, a marvel of geometry and ingenuity. The Romans perfected this technique, using it to create vast, open interior spaces like the Pantheon's iconic roof. By carefully balancing the forces of compression and tension, they achieved a sense of openness and grandeur that had never been seen before. The dome wasn't just a roof, it was a statement of human ambition, a testament to what could be accomplished when creativity met technical skill. And let's not forget concrete, a material so versatile it became the backbone of Roman construction. Unlike the brittle, temporary mixtures used by earlier civilizations, Roman concrete was durable, waterproof, and could be molded into almost any shape. This allowed builders to experiment with new forms and designs, from intricate baths to sprawling marketplaces. Historians often point to concrete as one of the key factors behind the Roman Empire's architectural dominance, enabling them to construct cities that stood the test of time. These innovations didn't just transform the ancient world, they laid the groundwork for future generations. The principles behind the arch, the dome, and concrete are still used in modern architecture, proving that the ingenuity of ancient builders continues to shape our world. But what's even more fascinating is how these advancements spread. Through trade, conquest, and cultural exchange, these ideas traveled far beyond their origins, influencing countless civilizations and leaving a legacy that spans centuries. Speaking of cultural exchange, that's a story worth exploring next. One of the most fascinating aspects of ancient construction is how ideas and techniques traveled across vast distances, often without the modern tools we take for granted today. Civilizations didn't exist in isolation, they exchanged knowledge through trade, conquest, and migration, creating a rich tapestry of shared innovation. Take the relationship between the Greeks and Romans, for example. Roman builders were deeply inspired by Greek architecture, adopting elements like columns, arches, and the use of symmetry. But they didn't just copy, they adapted and improved upon these designs, creating structures like the Colosseum that stood as testaments to their ingenuity. This exchange of ideas wasn't limited to Europe. The Silk Road, stretching from China to the Mediterranean, wasn't just a trade route for goods, it was a highway for knowledge. Along this ancient network, builders shared techniques, materials, and even entire architectural styles. Islamic architecture, with its intricate geometric patterns and towering minarets, spread far and wide, influencing buildings from Spain to India. The Great Mosque of Cordoba, for instance, showcases this blend of cultures, with its horseshoe arches and ornate mosaics reflecting a fusion of Islamic and local traditions. Experts point out that this cultural exchange wasn't just about aesthetics, it was about solving practical problems. When builders from different regions came together, they brought with them unique solutions to challenges like structural stability or climate adaptation. This collaborative spirit allowed ancient societies to push the boundaries of what was possible, creating structures that still awe us today. But while human ingenuity played a huge role, it's worth noting that nature often had a say in shaping ancient architecture. From earthquakes to floods, natural disasters forced builders to rethink their methods and innovate in ways that sometimes outlasted the very civilizations that created them. And that's a story we'll explore next. Ancient builders weren't just creating monuments to stand the test of time. They were also engineering solutions to survive the unpredictable wrath of nature. Imagine living in a world without modern technology, where earthquakes could topple cities, floods could sweep away entire settlements, and storms could destroy years of hard work in moments. Yet somehow, ancient civilizations rose to the challenge, designing structures that not only endured but thrived in the face of these disasters. Take, for example, the ancient Japanese, who developed a unique approach to earthquake resistance long before seismology became a science. Their wooden pagodas, like the iconic Horyuji Temple, were built with flexible joints and interlocking beams that allowed the structures to sway during tremors rather than collapse. It's a testament to their ingenuity, using materials that could bend without breaking, much like a tree in the wind. Meanwhile, in Mesopotamia, the cradle of civilization, builders faced a different kind of threat: relentless floods from the Tigris and Euphrates rivers. Instead of fighting the water, they worked with it, constructing elevated platforms and intricate drainage systems to protect their cities. One remarkable example is the ancient city of Ur, where layers of mud bricks and bitumen were used to create water-resistant foundations. Archaeologists have noted how these techniques not only prevented flooding but also kept the structures stable for centuries. It's a reminder that ancient builders weren't just reacting to disasters, they were anticipating them, using their deep understanding of the environment to create solutions that were both practical and innovative. What's truly fascinating is how these ancient techniques still hold lessons for us today. Modern engineers studying these designs have found that many of these ancient methods, from flexible joints to reinforced foundations, align with principles we now consider cutting edge. It's a humbling reminder of how much wisdom was embedded in the practices of the past. And as we uncover more about these ancient innovations, it becomes clear that their resilience wasn't just about materials or design. It was also about the vision and leadership that guided these projects. Speaking of which, let's turn our attention to the role of leadership in ancient construction and how the decisions of rulers and thinkers shaped the world we're still marveling at today. Leadership played a pivotal role in the grand construction projects of the ancient world. Without the vision and ambition of powerful rulers, many of the architectural wonders we marvel at today might never have been built. Take, for example, Emperor Vespasian of Rome, who initiated the construction of the Colosseum in the 1st century. This massive amphitheater wasn't just a testament to Roman engineering. It was a bold statement of imperial power and a gift to the people, designed to host gladiatorial games and public spectacles. Vespasian's vision wasn't just about creating a structure, it was about solidifying his legacy and reinforcing the might of the Roman Empire. Similarly, the Great Wall of China stands as a monumental achievement driven by the ambition of Qin Shi Huang, the first emperor of unified China. His vision extended beyond mere defense. The wall symbolized unity, strength, and the enduring power of his reign. But such projects weren't just about personal glory. They required vast resources, from manpower to materials, and the ability to organize and sustain efforts over decades, or even centuries. Leaders like Qin Shi Huang and Vespasian didn't just dream big, they had the authority and determination to turn those dreams into reality. What's fascinating is how these leaders used construction to leave a lasting legacy. They understood that buildings and monuments could outlive them, preserving their names and achievements for future generations. The Colosseum still stands as a reminder of Rome's grandeur, while the Great Wall continues to symbolize China's resilience and ingenuity. These structures weren't just feats of engineering, they were carefully calculated acts of preservation, ensuring that the stories of these leaders would endure long after their reigns had ended. And this brings us to the broader question: how did ancient societies preserve these structures over centuries? What methods and philosophies did they use to ensure their monumental achievements would stand the test of time? The answer lies in a combination of innovation, tradition, and a deep respect for the past, a topic we'll explore next. The endurance of ancient structures is nothing short of remarkable. Take the Pantheon in Rome, for instance, a marvel of engineering that has stood for nearly 2,000 years. Its massive dome, made from concrete mixed with volcanic ash, remains the largest unreinforced concrete dome in the world. The Romans didn't just build for their time, they built for eternity. And yet, the Pantheon is just one example of how ancient builders created monuments that defied time. Across the globe, the temples of Angkor Wat in Cambodia stand as another testament to this ingenuity. Built from sandstone blocks so precisely fitted that they required no mortar, these temples have weathered centuries of monsoons and tropical heat. But what made these structures so resilient? The answer lies in both the materials and the methods. Ancient builders often relied on locally sourced materials that were not only durable but also naturally resistant to their environments. Limestone, granite, and volcanic tuff were common choices, each selected for its strength and ability to withstand the elements. Techniques like interlocking stones, precise alignment, and strategic drainage systems further ensured stability. The ancients understood their landscapes intimately, designing structures that worked in harmony with nature rather than against it. Today, preserving these ancient wonders presents its own set of challenges. Conservationists face the daunting task of balancing restoration with authenticity. Modern interventions like reinforcing foundations or cleaning surfaces must be carefully planned to avoid altering the original character of these sites. Climate change adds another layer of complexity, as rising temperatures and extreme weather threaten to accelerate decay. Experts are now turning to ancient techniques for inspiration, studying how these structures were designed to endure. By combining traditional knowledge with modern technology, they hope to safeguard these treasures for future generations. The legacy of ancient builders is more than just physical. It's a lesson in innovation and foresight. These structures remind us that great achievements require not only skill but also a deep understanding of the world around us. As we marvel at their endurance, we're left with a question: what can we learn from their timeless wisdom as we build for our own future? As we wrap up this journey into the world of ancient builders, it's impossible not to be struck by their sheer ingenuity and resourcefulness. These masterminds of the past achieved feats that still leave us in awe today, crafting monumental structures without the aid of modern machinery or technology. From the precision of the pyramids to the grandeur of Roman aqueducts, their work stands as a testament to human creativity and determination. Think about it. Every stone, every column, every arch was shaped by hands and minds that relied on observation, experimentation, and an unwavering drive to push boundaries. What's even more remarkable is how these ancient achievements continue to inspire us. Modern engineers and architects often look to the past for solutions to today's challenges, drawing lessons from the durability, sustainability, and sheer brilliance of these ancient designs. The past isn't just a collection of stories, it's a living, breathing source of knowledge that shapes the way we build and innovate in the present. So, the next time you gaze upon an ancient structure, take a moment to appreciate the legacy it represents. These are more than just stones and mortar, they're symbols of what humanity can achieve when creativity meets perseverance. As the saying goes, the past is not just a story, it's a blueprint for the future. Let's carry that wisdom forward, finding inspiration in the triumphs of those who came before us. If this exploration of ancient ingenuity sparked your curiosity, I'd love to hear your thoughts in the comments. What ancient structure fascinates you the most and why? Don't forget to subscribe and join me as we uncover more historical mysteries together. Until next time, keep exploring, keep questioning, and keep marveling at the incredible legacy of our ancestors.